Hey guys, so this is going to be part 3 of our Intro to Electricity and Circuits unit. Just a few essential questions that we're going to address during this lesson is 1. What is a schematic diagram? 2. What symbols are used to represent common electrical components? So far we've just really seen different circuits that use like the actual picture of a light bulb, of a battery, of a resistor within a circuit, but there are actually symbols that represent different electrical components when we are drawing schematic diagrams. And last but not least, number 3, how do we draw circuits using different symbols in the form of a schematic diagram? I'll show you kind of some examples of that before we do some practice. So just as a quick review, we have 2 types of circuits that we're focusing on. We have a series circuit. In a series circuit, there's only one path for current to flow. So if you follow the arrows around the circuit, you'll notice there's only one path, kind of one loop for current to flow. And then we have the parallel circuit, where there are multiple paths for current to flow. So you can kind of see here, once you go from the positive side of the battery, once you get to this node, there's kind of 2 different options or 2 different paths for current to flow once you get to this point in the circuit. And then when you get to the second light bulb, the same thing. Third light bulb goes all the way around. So that's just a quick review. So what is a schematic of a circuit? It's kind of a complex name for really just a drawing. It's a graphical representation of an electrical circuit, so really just a drawing. It uses graphic symbols rather than realistic pictures. These symbols are kind of like universal, so it's almost like a language that's used to represent different circuits. So anyone in the world would be using these same electrical pictures, electrical component pictures for a circuit. So no matter where you are, you're kind of able to understand what's going on within a circuit. And they're used for designing and properly constructing circuits. So you can draw one, a schematic of a circuit if you're designing a new circuit, but also you may be given a schematic of a circuit and you need to construct it. You need to use it kind of as a roadmap or a blueprint in order to build that circuit yourself. So there are many different variations or symbols that exist for different electrical components. We have kind of a set that we're going to use just so we're all on the same page, but just 3 different pictures here, all using different symbols to represent a lamp or a light bulb within a circuit. So we have this lamp up here, kind of with this swirly piece with a circle around it. We have this really simple light bulb, which is just a circle with an X. And then this one almost looks like the one on top, but instead of the swirly, it's just like a little zigzag within the lamp. So it can be kind of confusing because there are different symbols that exist for different electrical components, but I'm just going to quickly show you which ones we're going to be using in this class so we're all on the same page. So let's start simple. First one is a battery. When you're drawing a battery, it's really just 4 horizontal lines, 2 longer, 2 shorter, and then with 2 kind of wires sticking out, so components can be connected to it. Remember we talked in either part 1 or part 2 how batteries are polar, so there's a positive side of a battery and a negative side of a battery. For this class, you kind of always want to draw the battery in this orientation, just so you like do the same thing every time so you don't get confused. I always draw the battery with the positive side on the top and the negative side on the bottom. This is how I remember it. If you start with the long side or the long line of the battery on top, the short side's on the bottom. This short side of the battery looks like a negative symbol, so that's the negative side. The long line of the battery is the positive side. That's how I remember it. You might come up with a different way to remember it, but that's kind of the easiest, and that worked for a lot of students last year as well. Moving on to an LED. This LED looks really different from the light bulbs I just showed you in the last slide. This is how we will be drawing an LED. I don't always put these arrows here. As long as you have this wire coming in with a triangle, the line, and the wire coming out, you're good. So you'll see in some of my examples, I don't normally put these arrows there. That just kind of denotes that there's light shining from the LED, but we kind of already all assume that. We also talked about how LEDs are polar, so there's a positive side and a negative side. The side with the triangle is the anode, or the positive side. The side with the line, just the plain straight line, is the cathode, or the negative side. So I remember this by the line, looks like a negative symbol, so that's the cathode, and then we have the anode with the triangle. Again, you can come up with your own way to remember this, and I'll show you some examples at the end of this lesson. Then we have a resistor. Resistor is one of the easier symbols to draw. It's just, you got a wire coming in, you got a few zigzags showing the resistor, and then a wire coming out. That's really it. Sometimes you draw them horizontally, sometimes you draw them vertically. It really doesn't matter, but it's all the same. Probably the easiest symbol is a conductor or a wire. To connect your different components together, you just use a line, and that line represents a wire. So all your components are connected with wires if you were to build a circuit in real life. We just use a line to show it in a schematic diagram. Then we have a capacitor. Again, like most of our components here, a capacitor is also polar, so there's a positive and negative side. I always kind of mark which side's positive and which side's negative when I am drawing this in a circuit diagram or a schematic diagram, just so I kind of know what's going on and what's what, because it's really easy to get kind of mixed up here, but we're going to practice. So you have a line coming in, straight line down, little bit of space, curved line, and then a straight line. Again, we'll practice this as we're going through. Moving on, we have a potentiometer. A potentiometer, if you remember from our last lesson, is just a variable resistor. So this is kind of easy to remember. We use the same resistor symbol that I showed you a few slides back, but instead of just having the plain resistor, we add this arrow pointing down at the resistor, and that just shows that you can change the resistance. So if I were to slide the arrow one way or slide the arrow another way, you're kind of increasing or decreasing resistance because a potentiometer is a variable resistor. So I think this one's kind of easy to remember, just if you know what a potentiometer is to start with. One of the more confusing ones is a transistor. We won't get into transistors until kind of the end of this unit. As long as you know what it looks like, you don't really need to know how to draw it just yet. We're going to do some more practice building circuits before we get into transistors. There are 3 different wires that do get connected to transistors, so that can kind of help you memorize this a little bit, because there are 3 wires sticking out of the symbol. Another easy one is a switch. When we draw switches, we draw them normally open, just so it's easy to see. So in this case, this is an open switch. If you had this in a circuit, the circuit would not work because it's an open loop. But that's okay, as long as you draw it like this. It's kind of assumed that that switch can be opened or closed and kind of complete or turn the circuit on, or when it's open, the circuit is off. Last but not least, we have a photocell or a photoresistor. This also kind of is helpful because it's using the same symbol of a resistor, because it does provide some sort of variable resistance based on light. So you have your resistor, you have a circle around it, and then you have 2 arrows pointing in. That just shows that light is shining on the photocell or the photoresistor. And that kind of changes the resistance. Remember, another name for photocell or photoresistor is called an LDR, a light dependent resistor. So that can kind of help you remember that a little bit. Most of the time when we use arrows, that denotes some sort of light, either light shining out or light shining in of a component. So there are some kind of guidelines to follow when drawing schematic diagrams. The first one is that every part should have a distinct name. A lot of times we'll be drawing circuits that have multiple components. So if you have multiple resistors, for example, you may label one R1 for resistor 1, the second resistor R2 for resistor 2. Again, we're going to do some practice with this, but just kind of going through these guidelines is helpful. Number two, indicate the values of each part. If you have a really complex circuit diagram, you don't necessarily want to write the value of a resistor, for example, right next to the resistor. So you can kind of draw that off to the side and make like a key. So you can say that R1 equals 100 ohms, R2 equals 470 ohms, for example. And again, I'll show you an example on the next slide. Number three, all wires and components are aligned horizontally and vertically. We don't draw anything diagonally. That gets super confusing. So you either draw parts horizontally or vertically and connect them kind of in boxes. So we're really just drawing straight horizontal and vertical lines. Number four, use the correct symbol for the component in your circuit. Like I said, there's a lot of variation of symbols out there. There's a lot of different symbols out there for the same component. As long as you stick with the ones we went through in this lesson, you'll be good to go. Number five, all diagrams should be neat and drawn clearly. Again, it's like a blueprint. We've talked about blueprints already in the beginning of the year. You should be able to hand your schematic diagram to someone who's never seen it before, and they should be able to use it as a blueprint to build the circuit. So you want it to be neat and as clear as possible. And lastly, you're always going to show the direction of current flow in a circuit. We talked about the flow of current, and we also talked about the flow of electrons within a circuit. You never show the flow of electrons in a circuit. You always show the flow of current. Current flows from the positive side of a battery, if we're talking about a battery, for example, to the negative side of the circuit. Okay, so just kind of remember that moving through. Here's a quick example. We have a 9-volt battery. This was labeled VS because this is the voltage source. So everyone kind of labels things a little bit differently. It's really up to you. The red arrows here show the flow of current. So we can see if this is the battery, this is the positive side. So the current is flowing from the positive side. At this node, it kind of splits, goes to R1 or R2, can go all the way back through the circuit. It ends at the negative side. You'll also notice that there are 4 resistors here labeled R1, R2, R3, and R4. Instead of writing the value of those resistors right next to the resistor and kind of messing up this circuit diagram or the schematic diagram, I just decided to make a key on the side where it labeled what each resistor value was. Okay, so you definitely want to do that if you have a more complex circuit. We didn't talk about this type of circuit yet, but this is all actually called a series parallel circuit. So you can see that R1 is parallel to R2, R3, and R4. So those are wired in parallel, but R2, R3, and R4 are wired in series. So you can have a combo series parallel circuit. A lot of times most circuits are wired in series parallel. So there's a portion of it that's wired in series, a portion of it that's wired in parallel. So just as an example, we haven't gone through that type of circuit yet. All right, so we're going to do a little bit practice. So I wanted to be able to show you how to draw these circuits, and I know if we were in class together, we would be able to do this together, but this is just a simple circuit. And we talked about simple circuits already. Simple circuits need some sort of voltage source. So right here I have a battery. They need some sort of control, which is that switch that I just drew. The resistor can also be a form of a control because it's controlling how much current is going in the circuit. Then I have my LED, which is a load. And all those wires that I drew here are conductors. Sometimes I like to use a different color to show the flow of current. So that's those red arrows. Don't go crazy with the arrows. Then I just labeled the values of the battery of 9 volts and the resistor of 100 ohms. Let's see if I can go back there just to show you. There we go. So that's kind of the finished circuit. Everything's labeled. So this is the most simple circuit you can build. Definitely use this as an example if you get confused moving forward. Here we have a series circuit, and there are kind of two options for how you can draw this. So let's take a look. So again, I'm starting with my battery. I like to always draw the positive side of the battery on top, just so it's consistent. I have one LED, a second LED, and a third LED, all connected by wires. So those are all in series, even though they're kind of on different sides of our box, if we're talking about the circuit as a box. So here I labeled the flow of current, which is my red wires. Again, don't go crazy with the arrows showing current. You don't want to kind of messy up your circuit diagram with all those arrows. And then last but not least, I labeled the battery of 9 volts. You don't necessarily need to label the LEDs in something as simple as this. So just to show you a different style of drawing a series circuit, it's going to be the same circuit with 3 LEDs, just drawn a little differently. So we have the battery starting with the positive side on top, wires coming out. I got my first LED, my second LED, my third, and see here they're all positioned on one side of the circuit. That's okay. It's totally fine if you draw your circuit like that. Let's go back to the end here. There we go. So here I didn't label anything because it is the same exact circuit that I just showed you on the last slide. It's just drawn differently. So this circuit is the same as having one LED here, one here, and one here. It means the same thing. It doesn't matter where you put these LEDs as long as there's only one path for current to flow. It is a series circuit. So just know that. Lots of different styles. Here we have a parallel circuit. So I start with the battery again, positive side on top, wire coming out. I have my first LED, my second LED, and I'm doing my best to draw this as neat as possible here, and my third LED. Going to go through and label the flow of current. And this is a parallel circuit because there's multiple paths of current to flow, and also all 3 LEDs are parallel to each other. And then I label 9 volts. Most basic parallel circuit. It's easy to remember if you just know parallel circuit, the components need to be parallel to each other, and you can see that all 3 of those lines are parallel. And the last type of circuit is a series parallel circuit. Just wanted to show you how to draw this one too. Start with a battery, positive side on top. Got a resistor. I got an LED. I'm going to do that same thing on this branch of the circuit. Show the flow of current. You don't have to do it in a different color, but if you want to, that definitely is helpful. Label 9 volts. That's R1, R2. Then I make a key on the side so it doesn't get messy. Let's go back just so I can show you what it looks like at the end. All right, so it's a parallel circuit because there's multiple paths for current to flow, but it's also a series circuit because R1 and this LED are in series, R2 and this LED are in series, so it's a combination. Most circuits, like I said in the beginning, are going to be series parallel, so I just wanted to show you a quick example of how to draw those.